All right, so now we're into modern atomic ideas, which is going to be something called orbitals, quantum numbers, and energy levels. There's going to be a video that I want you guys to watch. Here's the link for it. It's also, however, on the worksheet in the packet. Same link. You just go ahead and type that in. And please answer the questions. Once you're done watching it, you can feel free to continue in this video. Basically, the remainder of this video is going to be very short. I'm going to just recap a couple portions of the video, but it's not going to be enough to answer those questions. You're actually going to have to watch the video. The video is about 6 minutes long. Um, and yeah, okay. The first guy that I'm going to talk to you guys about is Niels Bohr. He was basically kind of like an accepted failure. He was important in history, but scientifically, his ideas were sort of inaccurate. Now, what Niels Bohr did was he tried to decide, well, where is the electron in the nucleus? So this little center red dot right here, this is the nucleus of my atom. And these rings are where an electron must orbit. It could orbit on this ring, it could orbit on this ring, it could orbit on this ring. If I had another ring on the outside, it could also possibly orbit on that. Now, the thing about Bohr is you had to be on one of these rings. It doesn't matter if you were on this one, you could be on this one, you could be on this one, but you had to be on a ring. You could not be in between. You had to be on a very specific calculated ring, no in betweens. He called the idea of specific orbits, but the bummer was that his math only worked for hydrogen. When he tried to apply his math to different elements, the numbers didn't quite match up. So he was kind of like close, but no cigar. Um, the formula that he used right here, I'm merely just showing this to you just so you could see what it is. We're not really going to discuss this formula, but this was his math that he used in order to solve it. Again, it only worked for hydrogen. The next guy you will find in the video, his name was Heisenberg, and if you guys are Breaking Bad fans, this is the guy that he was emulating, I guess. Basically, what Heisenberg says is about 90% of the time they'll be next to the nucleus. However, it's only an estimate. He had an uncertainty principle. He said it's impossible to know both the velocity and position of an electron at the same time. Like, I might know how fast the electron is going, but I can't know its position. I might know its position, but I don't know its velocity. I cannot figure out both. But he said about 90% of the time, those electrons would like to be next to the nucleus. And then to just elaborate a little bit more with Heisenberg's idea, let's say I could take a microscope and point it at an electron. As soon as that light from the microscope hit the electron, it wouldn't be there anymore. It'd be off and moving. It'd be like an endless chase to track down these electrons. Every time you think you might find it, as soon as you hit some light on it, it would energize and it would move away from where you originally had it. Unlike if you ever took biology and you had like amoebas, when you flash a light on an amoeba, they're not zipping, zagging, moving all around. They kind of just go really slow. An electron, however, when you point a microscope at it, as soon as you flash the light on it, it'd be gone. Now, I just want to compare two different ideas that you found out in those videos. Niels Bohr, he had the idea of specific orbits. It could not be outside of the orbit. You had to be on a ring, no in-betweens. De Broglie and Schrodinger, who you heard about in the video, they had orbitals based on a probability. There was no clear idea where it was, but like 90% of the time they thought, okay, it'll be near the nucleus, and the odds of it being farther away get less and less and less. Yeah, in this picture here, it's very dark in the center because 90% of the time it's near the center, and as you move out, the probability goes down, hence the fading color. And then out here, it's all white. Okay, that's going to be it for this video. Our next video, we're going to talk about quantum numbers. Quantum numbers are a little hard for people to understand. I'm going to try to break it down and kind of put it in the easiest terms as possible, but that'll be our next video. Don't forget to watch that previous video that we talked about in the beginning and answer those questions. Again, here's the link one more time right here. It's on that page. Make sure you go to that link, watch the video, answer those questions, and that is it.